இது ஓகே தானே? Very good morning to one and all, and warm welcome to you all. This is PSR Engineering College Sivahasi, Department of EEE, organized 1 week, 6 days faculty development program on research opportunities in electrical engineering and its applications. Now, we are in second day program. Dear professors and participants, we have licensed version of Zoom. So, during program, we can collect your attendance in the Zoom itself. So, no need to type your name and designation in the chat box. Even though we have licensed version of Zoom app, there is a technical issue which makes us to get out from the Zoom room. We contacted Zoom officials to resolve, but due to limitations of employers, within 24 hours, this issue will be resolved. If you have any issue like this, please rejoin immediately. After each day session, we will post feedback link in the chat box. Based on all 6 days feedback, we will issue participant certificates to you. During session, if you have any doubt, you can type your questions in the chat box. After the session, you can raise your hands and ask questions to the resource person. Dear participants, one more good news for you. Online streaming of this program is also available in the YouTube channel. Its link is displayed in the chat box. We can share this to your students, colleagues, and friends. Today's resource person we have is Engineer V. Selva Ganesh, Electrical Project Engineer, R&D Plant, Engineering and Design Private Limited, Kapalur, Madurai. Today's topic is electric vehicle. Welcome to Dr. V. Selva Ganesh, sir. Please take over the session, sir.
Yeah, sure. Yeah, very good. Very good morning. Good morning to all.
Okay, sir. Good morning, sir. Share your PPT, sir.
Yeah, sure, ma'am.
Okay. Okay.
Yeah, very good morning. I'm Selva Ganesh. I'm working as a electrical project engineer in Total Plant Engineering and Design. And today's topic is electrical vehicle. We are going to see the electrical vehicle concepts and what are all the recent methods they are doing in India and all over the countries. Before seeing the electrical vehicle, let me thank to PSR College of Engineering and their staff for making this wonderful session. And I'm giving a very much thanks to my company, Total Plant Engineering and Design Private Limited. Actually, what we do here is we have a design process. We do engineering and design process like site survey, junction box verification, loop drawings, operator training, and smart plant instrumentation, PLCs, SCADAs, more and more. So if you need any thing, you can directly contact Total Plant Engineering and Design for the further one. Okay, let's start the session. Today's topic is electrical vehicle, right? See, these are all the content we are going to see right there. First of all, we are going to see about the introduction about electric vehicle, then electric car, components of electric vehicle, and then finally we are going to see the charging stations. So I have represented everything in the picture format. So with those pictures, I'm going to explain everything to you. This session will be quite interesting, and it will help you for many projects and many PhD scholars to do further. Okay, let's get into the topic. So what do you mean by electric vehicle? Why we are using the electric vehicle? Before seeing the electrical vehicle, there are a few issues going on there. That is called greenhouse gases, called CO2, SF6, CH4, N2O, HFC, and PCF. These are all greenhouse gases. So these common 6 gases plays a vital role and affects our environment. So, and this leads to global warming, etc. So see, this carbon dioxide, by doing the process of combustion, carbon dioxide is liberated. Then sulfur hexachloride, methane, nitrous oxide, hydrofluorocarbon, perfluorocarbon. So these are all the sources where we are getting it from. Okay, right? So by electrical transmission and distribution, also we are liberating sulfur hexachloride. So for like ozone depletion and manufacturing of semiconductor devices. So these are all the issues. Greenhouse gases liberate. So automatically global warming increases. So see the picture right here. Annual greenhouse gas emissions by sectors. Okay. See, the carbon dioxide is 72% of total. Methane is 20%, and nitrous oxide is 5%. So this leads to a climatic change and lies in global warming. So in order to limit and dissipate these kinds of issues, we are concentrating on EV. Okay, that is called electrical vehicle. Why electrical vehicle? See there are lots and lots of air pollution and smokes and hazardous gases. Okay, so by using this e-vehicle, charging your EV on renewable energy such as solar, wind. So this helps in greater manner. So we won't get any side effects like there is a shortage of due to thermal plants and other plants. There is a shortage of coal, natural. Okay, so in order, if you are using a renewable sources, we can mitigate this, right? Then, so according to the latest criteria, see, transportation accounts for 1/3 of all energy usage. By let's see these images, right? How much of smoke they are liberating. If we are mitigating, we can able to minimize the global warming and other major issues. Let's call it air pollution issues, right? Then coming to the capital cost and maintenance, actually it's maintenance free. Actually, it should maintain very much. And then availability of fuel. So fuel availability depends upon the renewable energies only. So we don't need to think that. So let's see the historical background. So this is the historical background. During 1907 itself, Thomas Edison have a huge idea that we are going to enter into the new electric vehicle economy. Okay, on that time itself, he have think this much of issues. See, the energy crisis of 1970 and 1918. There is a lot. All the electric vehicle engineers should know. There is a large energy crisis during 1970s to 1980s. Okay. So that causes the engineers and other scientists to do the electric vehicles. So let me explain the historical background. Okay, this is the first electric vehicle car by Siemens. Okay, Siemens on 1904. On that time itself they have made, right, and then it's a company of Trebelhorn. During 1961, they have done the name called Henny Kilowatt and Vanguard City Car. That is in 1974. Applications they have made to their
Excuse me, sir. Can you hear me? Mr. Selvaganesh, sir? Mr. Selvaganesh, sir, I think some audio problem, sir. Mr. Selvaganesh, sir? Hello. Selva sir. Sir.
Hello, hello, Selvaganai sir.
Into two types called neighborhood electric vehicle, NEV, and battery electric vehicle. That is called BEV. See what's happening there is purely it's running only on the battery only. It's not running on a gasoline. It's purely running on batteries only, right? Okay. Let's have a deeper session. See operations in EV. Okay. The first one is called a DC operation. See what is a DC operation in the sense. See the image from the left side, utility from the electricity board. From the utility from the electricity board, you can use a rectifier circuit called AC to DC rectifier circuit to charge the batteries, because batteries cannot be charged with the AC, right? You can charge only with the method of DC, as if already we are no. So, and this is called AC charging method. Right here you can see this is AC charging method by using the solar panels or wind and whatever it may be the renewable energy sources. Using those renewable energy sources, you can by using the equipment called a charge controller, that is called DC to DC charge controller, we can able to charge the batteries. So this is called a DC charging method by whether the batteries can be charged with any one of the method only at a time we cannot able to do. So we can able to charge with the AC charging method or DC charging method to charge the batteries by it is connected to the DC to DC. Another it will connect to the DC to DC controller and it will connect to the motor. When you are pushing the accelerator of the car or throttle of the bike, you can able there is a electrical signal, that is electrical signal that gives us a feedback to the DC to DC converter. Right here, the person is using his accelerator where the potentiometer is connected. Automatically, it gives a feedback to the DC to DC controller. Okay, and it drives the DC motor accordingly. If you want to increase the speed, if you want to decrease the speed, if you want to stop, that is called regenerate. If you want to regenerative braking method, and this feedback method helps the controller whether to work or not, right? Actually whether to operate the DC motor or not. So automatically the DC motor will connect it to the wheels, so this wheel can run, so we can move from one place to another, right? So second one is AC operation. See, don't confuse with this. First one is we have seen is the DC operation, is the AC operation. Same diagram only I'm using. Same utility from the electricity board. I'm charging the batteries. So from using the rectifier circuit AC to DC, I'm charging the batteries. Also for the renewable energy sources, I'm the DC to DC control. I'm the method of DC charging method. See, there is a major difference. I have used this DC to DC controller in DC operation. See, in AC operation, I have used DC to AC controller, right? So DC to AC controller. So why we are using DC to AC controllers? Because we are having a AC motor right on the right hand side. That is called a load side, where this AC motor we connected to the wheel. So we can move from one place to other, right? So similarly, the person is using his accelerator or throttle, like for e-bike is using a throttle, it will get a feedback, electrical sensation, feedback to the controller, and it starts working accordingly. Okay. to satisfy the rated voltage and rated current of a AC motor. Right? So let's go into the topic that called components of EV. It's a main topic, components of EV. Okay. I'm comparing the both. I'm comparing both topic. Okay, I'm comparing both AC operation and DC operation right here. What we have seen before. See, the first image is the DC operation. The second one is the AC operation. Okay. See this DC operation and AC operation. What are all the main thing is first one is first one is batteries. Okay. See, first one is batteries. So we are going to see the batteries right here, and then electric vehicle energy supply. So this electric vehicle energy supply consists of two methods called AC charging and DC charging. Okay, so this AC charging and DC charging we are going to see at the end of the session. It will be quite interesting, right? And these are all the power conditioning units called DC. Fourth point, power conditioning unit, charge controller, DC to DC and the DC to AC controller. It is called inverter, DC to AC options. So, and finally, we are going to see the DC and AC motor. Okay, let's go to the components of first session, batteries. So, as if we have studied earlier and if you have seen earlier, these images and all, there are two types of batteries, primary battery and secondary battery. So, primary batteries are non-rechargeable and secondary batteries are rechargeable, right? Then, this is a cycle that where electrical energy is converted into chemical energy and chemical energy is converted into the electrical energy. And this is the chart of on-off conditions. See, here rechargeable battery types. These are nickel cadmium batteries, nickel metal hydride batteries, flooded lead acid battery, valve regulated lead acid battery, lithium ion battery. These batteries you have seen the day-to-day life, right? Okay. Then, sir, coming to the point, what I'm concluding is, we are having lots and lots of variants in rechargeable batteries. Which battery will choose for e-vehicle, right? Coming to the point, lead acid battery is flooded lead acid battery. See the first point, first column. Lead acid battery is applicable only for the solar PV application. So automatically we does not need this requirement. So coming back to the second step, valve regulated lead acid battery. So it can be applicable for both PV and electric vehicle applications. See the lithium ion batteries. Why am I using a red color font here is because in recent trends they are using the lithium ion batteries only. Okay, these are all the recent trends. Why they are using lithium ion batteries in the sense why they are using lithium ion batteries in the sense they are actually the maintenance free batteries and they can be fitted in on the any positions. Okay, so no water refilling is required and no acid leak issues. See, in a valve regulated batteries, when during the started time of, that is the initial time of e-vehicle, they have used the valve regulated, that is the shield maintenance batteries right here. Okay, due to the heavy weightage and some amount of maintenance and minimum issues, some of the issues they have faced, so they are transferred into lithium ion batteries. See, they especially designed, and this lithium ion batteries is very weightless and designed only for the electric vehicle applications. Also, some of locations they are using for PV applications. But if you ask me, I would tell you that better for PV application you can choose VRLA batteries and flooded acid. For electric vehicle, for better performance and better efficiency and for efficient purpose, you can use a lithium ion batteries right here. Okay. Anyway, I will tell about the types called flooded lead acid battery. See, these are all the tall tuber battery which you have seen in the day-to-day life in your home, in your office, in your work location, right? So these are the flat plate batteries. Okay. Tall tubular batteries and these are flat plate batteries. So to the valve regulated battery, this will be much weight and it's similar to the similar to the FLA batteries to fill the distilled water right here, and it have a gel type. Okay. The next one is the lithium ion battery. So see the size of the lithium ion battery, how much size it is. So for example, I am rewinding that. See the lead acid batteries, how much tall in size, and see the size and see the dimension of these batteries, right? You can see this you can compare this dimension of the battery. It's very small in size and less in weight. See, you can able to have a 150 Ah of battery with this dimension itself. Okay, so it can be placed inside the electric vehicle and you can travel more and more. Okay. Okay, let's coming to batteries data sheet. It's a basic thing. Kindly you can note it down, or if you do something, kindly note it down. And this is the important thing we are going to see in the batteries. So this is the major thing which satisfies all the criteria of electric vehicles, because if an electric vehicle runs only on the batteries, so battery is the important thing. We have to take work, right? So and we are going to see about that. What is the terminal voltage? See the black color capacity, and this is efficiency and the C rating. See, the nominal voltage is 12.8 volt, 150 Ah, 27 degrees Celsius, and C rating is C5 rating, right? So these are all the rating of the simple lithium-ion battery. And there is an important rule that charging current should be 20% to 30% of the capacity for lithium, especially for lithium-ion batteries. See, I'm calculating 20 divided by 100. It's called 20% of 150 H, 30 amps, and 30% of 150 H is 45 amps. So minimum charging current and maximum charging current, right? So the user should give 30 amps to 45 amps to charge the battery. So not below that. If you give below that much of charging current, the charging time will increase. So these are all the series connection. If you are connected the batteries in series, you will automatically the voltage adds up and the current will remain the same. So this will be helpful in designing the EV vehicle. So EV vehicle design consists of so much of parts. In that, battery is also the major terms. And also especially see the battery parallel connection. By paralleling the battery connection, the ampere hour rating will be improved and the voltage remains the same. Okay, so these are all the electric vehicle voltage capacity. So 6 volt and all they won't use. So minimum the starting voltage is 12 volt to 120 volt. For namesake, I have just coded, right? So 12 to 120 volt. Okay, these are all the charging chart. Whether you can check with the multimeter to have whether your battery is in good condition or if you want to charge the battery, right? So this is charging current. See right here, this is the formula. Charging time is equal to capacity H divided by the charging current. When the charging current is 30 amps, automatically the charging time 150 divided by 15 is 5 hours. You can able to charge the lithium-ion batteries in 5 hours. So as you make faster the charging, you can able to travel more and more, right? Okay, so the charging time will be reduced. If the charging if you have improved the current 3.3 hours, it will charge, right? Okay, so battery AH efficiency. So sir, you can ask that what is AH efficiency? So you have to concentrate on the AH efficiency also, where charging time for 150 AH is 10 hours means, where charging current, if you are giving 12 amps for a specified lithium-ion battery means, actually you can able to give more than that is, you can able to give 30 to 40% of charging current, but due to some situation you cannot able to give that much of specified current means, the automatically the charging time will increase. So here I have specified that discharge time is equal to load user. Load user is nothing but the person's traveled from one place to another by using this electric vehicle, and this is the rated load current. So overall, he is consuming 10 amps of current to travel specified location, one place to another place, right? So by substituting all those values, see the battery efficiency is 83.3%. And similarly, WH efficient, that is called watt hour efficiency. Same thing I have used here, discharging voltage time current, discharging voltage time and current. Okay, charging time and discharging time. By substituting all those values, you can also calculate watt hour efficiency. So, and the next point is C rating. So many people are saying C rating or much more important. So I'm also telling the same point that C rating is very important. So don't want to get into depth of the session. I'm simply telling the thumb rule called, if the capacity of 150 Ah at a C3 battery rating, the current you will get the current of 50 amps for 1 hour. Okay. See, this and all for only 1 hour. And the capacity of 150 Ah at C5 rating means you can divide the capacity divided by the C rating for 30 amps. So the battery's capacity can deliver 30 amps for 1 hour. Similarly for C10 rating and C20 rating. Okay. So these are all the thumb rule we should have, right? Then EV battery pack. These are all the battery packs they are going to fit into the electric vehicles. See, this is the first image is a Tesla battery pack. See how they are assembling. Then see the next one, Nissan battery pack. So that up to for model to models, they have been changed their chassis right. So these are all the battery pack. Then coming to the point, DC motor. Sir, you can ask what is meant by DC motor? Okay, so we have all studied electrical machines. So so with the same concept only, DC machines. Actually, it's simpler to maintain, more durable, smaller, 85 to 90% more efficient, and able to self-start, and it have a less failures. Okay, so let's get into the DC motor. So these below images are all a lower end market availability DC motor. Okay, if the motor is a DC, it may run anything to 24 to 192 volt. Okay, you can have a data sheet of the specified e-bike DC motor, not AC motor, DC motor, and you can see the data sheet whether what type of voltage and what type of current we have to do. That is called rated voltage and rated current. That is power. What are all the things we have to give? And you can see on the data sheet there are two types of electric motors in DC called brushless DC motors and brushed DC motor. So it depends upon the load. Okay, third point. See the third point. Depends upon the load. That is, the person traveling on a vehicle results in increase in wattage rating. Okay. Next, coming to the AC motor. See, this is one of the Siemens AC induction motor. So AC motor in the sense automatically it's a AC induction motor. See the specific size, shape, or the power rating easier. So we can able to give order to the specified manufacturing unit. Okay, then and it has a regenerative braking feature. And see the third point, when comparing to the DC motor, AC motor is a good one. Why? And efficiency is also good, but it consumes more current, and its work nature is much more complicated when you are comparing to DC application, because you have to use inverter, that is inversion operation, that is called DC to AC. DC in the sense battery is DC, and you have to convert DC into AC, and you have to give input to the AC motor. True, AC induction motors are much more expensive than DC induction motor. This performance of cars can be much more improved. So for racing purposes and other purposes, they are using AC motors only, not they are using DC motors. Okay. See, these are the lower end electric bike AC motor. Okay. See this image, and this is the AC motor, and he have installed inversion operation. That is called inversion, power conditioning unit called inversion. It gives input to the control, right, to the motor. Okay. Then this is one of the Tesla machine where have a 3-phase AC induction motor, produces a 460 HP, 5,600, 8,600 RPM. So it will be much more equal to the normal combustion vehicles. So it gives a greater performance on normal vehicles, right? Then power conditioning unit, AC and DC controller. So last topic, so inverter controller. This is a DC to E. Okay, and this is the power conditioning unit, AC and DC controllers, right? We are going to see this. So as the same image, I am repeating for your convenience. See right here, the inverter controller, DC to AC is where I am using this. You can able to save this color. This is called I'm using this orange, this saffron color to have inverter control. That is called a DC to AC regulator unit. So automatically you can able to control the AC motor. For it's a green color. We are using this charge controller DC to AC. That is called a DC to DC operation to run the DC motor. So coming to the DC to DC regulator unit, what's happening inside the DC to DC converter? See right here, and this is see the image right here. It's a battery backup, okay, and it's a power converter. It is called a DC to DC converter, and this is the DC motor. Okay, let's say one thing that if you are traveling on a e-vehicle, suddenly if your friend stops on your road and he told it kindly drop it on a other place, means you and your friend are traveling on a e-bike, right? So on that time, automatically the load will increase, right? So the mechanical load will increase. So due to those, the operation of motor will starts reducing. So on such that time, this power converter give the rated current and rated voltage to the DC motor to travel in the same speed and without any loss. So if two or more persons are traveling on a same bike, e-bike or car, automatically the load increases and the speed automatically decreases. We all know the thumb rule that if the RPM of the speed of the motor increases, automatically the torque decreases. If the torque increases, speed decreases, right? So this is the basic thing that by using the battery backup, the power conditioning unit senses the battery voltage and battery current. Also, for a DC motor, it senses the voltage and the current of the rated current of the DC motor, and automatically there is a specified algorithm and duty cycle adjustments, and it gives the PWM generation to the power converter unit. See right here, and it satisfies the rate. Even though if you have you and your friend are traveling with some much of load, the speed will not reduce. So accordingly, this charge controller has been designed and developed, right? See how it's developed, and all these are all basic power converter, DC to DC converter topologies, buck conversion, batteries. Okay, battery and load, that is electric load. If you start the motor, automatically during the battery side, the voltage gets bucked. Okay, the voltage will reduce. Okay, and then the motor will start running. Right. This is called this is due to the magnetizing inrush. This is called the inrush current. It seems first the current will consume more current, and it starts coming to the normal float position. So by using these type of converters and specified algorithms, both the input and output side can be regulated, right? So, and these are all the DC to DC controller units. See, the first image, one of the car, they are using DC to DC controller with a heatsink also. Second one is also a DC to DC controller. So according to your e-vehicle design, load design, your travel distance, you have to calculate this, you have to sizing this DC to DC controller. Next one is inverter. We have completed DC. Next one is inverter regulator. See the saffron color. I have already specified inverter color. The DC to AC regulator unit. Actually, this DC to AC inverter, 3-phase for electric car automobile controller. So as I've told you earlier, we are using induction motor. We are using this 3-phase and also the 3-phase to get the vehicle run. Right. Major operation is the DC to AC input, which is a DC input from the batteries, and AC input, AC output to the AC output, and this AC output as an input to the motors. So, and coming to the point is actually how they are controlling the speed is, we all know speed N is equal to 120 F by P by controlling the frequency. Okay, if you are adjusting, you are using the accelerator or throttle means, automatically the power conditioning unit sensors and it reduces the frequencies accordingly to increase and decrease the RPM. See the fourth point, the accelerator pedal sends a signal to the controller which adjusts the vehicle speed by changing the frequency of the AC power from the inverter to the motor, right? Okay. And this is the expanded part of controller and the AC motor, what they are specifying. This is called a battery management system. As I've already told, battery management system is nothing but the charge controller. You are charging the batteries with a specified management system, which you are going to see later. And this is the inverter motor control. See the here, this is the inverter controller motor, and these are all the other units. So these are batteries. Okay. Coming to electric vehicle energy supply, AC charging and DC charging. Okay, let's discuss this session at last, because this will be resembles like charging stations. Let's coming to the point of chassis. This is the last one, chassis. See the first image and second image. First, see the second image. They are using the DC motor and the DC battery. Okay, so this battery, they are directly connected to the motor, and if you start the ignition switch right there, you can able to by using the throttle, you can able to move the electric vehicle. Okay, right. This battery is normal battery, this normal shield maintenance free batteries they are using. So they are initiating in normal locations and all. Right. Then top manufacturers in India, and this is the Ather 450, Revolt RV400, and these are all the types, right? There are the top manufacturers of India. You can able to purchase. You can Google it whether if you want, right? And these are all the top manufacturers of in India for making electric cars: Hero Electric, Tata Motors, Mahindra, 2020, and Hyundai. So these are all the top manufacturers. Okay, then. So coming back to the point, and this is the last session, charging station. This charging station is nothing but the we are going to use the charging station very much sooner, right? Okay. I assure that even now we are using a petrol bunks, right? So these petrol bunks will automatically change into the charging station, where all the there will be the option of putting the fuel, etc. But even though this charging station, we will charge the batteries and we move from one place to another. See, let's get into the topic. There is called a two topic called AC charging station and DC charging station. So DC comes under the fast charging, AC comes under the nominal, that is called the moderate charging. See, same image I am repeating from first PPT to last PPT because this is the base image we are using. Okay, then this is the AC charging station, and AC charging station by using the utility from the electric grid with a specified controllers, we will charge the batteries. Similarly, see the second one is called a solar source or any other renewable energy is called a wind. We can use this, okay, to charge the batteries. So benefits for public sectors. Okay, what are all the benefits for public sector in the sense? Logistics, like a heavy duty, light duty, retail industry, public transportation like Ola, Uber, etc. So what are all the public transportations, and even for buses, taxis, and public transportations. So these all public sectors will have a greater improvement within 2030. Yeah, I assure within 2030 everyone will change into electric vehicles, right? Okay. Okay. Charging station levels is level 1, level 2, and DC fast charging. And this is a typical duration of charge event for charging level 1, level 2. For level 1, it takes 6 to 10 hours, and for level 2, it takes 1 to 3 hours, and for DC fast charging, it takes only 30 minutes. So people are working on that to reduce the charging time. So we can reduce the charging time and have a cup of coffee in the charging station, and we can start traveling from one place to another. So it's a innovative thing that we are going to see, right? So these are all the level 1 and level 2 and level 3. That is called the DC fast charging. So that's coming to the topic of AC charging station. So sir, you can ask, what is the AC charging station? There are the 3 modes of charging in AC charging station. See, first one all, this mode 1 charging is the AC charging current can deliver a 13 amps current. Okay, 13 amps of current without any communication. Like, how can you say that? You cannot be able to see whether the battery is full. You cannot able to see the other options, that how much of charging current that much of. Simply you get the plug into the socket and switch on the circuit. Automatically it will get charged, and it took 6 hours to 10 hours of charging according to the capacity, battery age capacity, what you have installed in the EV, right? And this is mode 2 charging. See, there will be a in-cable control box right here. In-cable control box in the sense you can able to have emergency stop options and other live recording options also, whether the battery have charged. Like if you are using your mobile, right, you go to the battery settings, you can see how much it gets charged. You can see the nominal graph, right? These are all the method of mode 2 charging. It can charge of 32 amps. So see the mode 1, they are using a normal outlet socket. For mode 2, they are using this plug 2 socket, right? This have a higher level of charging current not exceeding 32 amps. So finally, the mode 3 charging, and mode 3 charging is the important one, and the sit down to one we are using is this in latest. Okay, there is a battery and onboard charger. Already an onboard charger regulator will be inside, and this AC charger, so outlet socket outlet plug, so EV inlet connector, so we can allow the communication between the EVSC and the onboard charger. Okay, so let me explain this in detail. If you are going to the petrol bunk, what you will do first is you will see the petrol or diesel level in your specified vehicle, whether how much it needed. So how much it needed, it depends upon the distance you will travel, right? So according to the distance, you will refill your fuel, and parallelly you will check your wallet whether you are having amount or not, right? So even though the distance we should travel, we should we should concentrate parallelly on the budget also. That is how much of fuel we have to refill. So this plays a vital role. So similarly, this mode 3 operation is a settle down final one. This allows the communication between the EVSC and the onboard charger. See what's happening right here is, if you go and place your RFID right here, that is for your number. Like FASTag, you are having a separate number, you are recharging, right? For example, you are using FASTag, you are recharging this FASTag card, and you are traveling from one place location to another, right? So similarly, you have to recharge your RFID card and go and place it on a AC charging station, and you can connect the and it get authenticated. First of all, it get authenticated. Why it's authenticated and have a fingerprint or any PIN number? Because maybe theft can happen right there, because someone have taken your car with right. So first of all, you can use the RFID card and gets authenticated and use a PIN or a fingerprint or a PIN number to authenticate your RFID card, and then you can connect the socket into the your electric vehicle, and automatically in this display it will show a communication between, there is a communication from the charging. That is called, it senses the battery's primary condition, whether it can able to charge, or the battery is in good condition or not, or the battery should be destroyed, or what are all the conditions it will show. So finally it will show the amount price. If you want to recharge, if you want to charge it for 100 rupees or 200 rupees or 500 rupees, according to the distance you can able to charge the battery. So this and all we are going to see within 2030. So better mark my words, all the fuel stations will change it to the charging station, right? Okay, this is a major one we are see right here, and these are all the sockets. These station, these are the charging plugs and sockets right here. Okay. And then AC charging station. Actually, this was installed in Delhi, New Delhi. See in the parking session, in the parking zone, they have placed the EV charging machine. This is called AC charging machine, where you can connect a charger. When you go to the office, if you go at the morning and you will get back in the evening. So during that time, you can able to charge your batteries of a specific car or a bike. So these have installed in New Delhi. The company called Exicom. Okay, this took a vital role in doing those things, right? Then this was a AC charging station. It was during the parking sectors. They have placed see for each vehicle they are keeping one charging EVSC supply equipment, electric vehicle supply equipment. Okay, let's see, similar to the petrol bunks they are using. So see, the Renault Nissan have installed car electric vehicle supply equipment for charging the cars. Okay, coming back to the DC charging station. Audience, the session will discontinue within 3 minutes, so I will reconnect. So kindly have patience. I will reconnect within 3 minutes. Actually, the session is going to end in 3 minutes. I will reconnect. Okay. So okay, this is called a DC charging station. Okay, coming to the DC charging station, this is the mode 4, right? Where DC charging station have mode 4 operation, and it will be a quick charging one. Similar to the AC charging station, DC charging stations also when comparing the AC charging station, DC charging station will have a lesser time to charge the batteries. As I've told you earlier, you can have a cup of coffee and you can chat with your friends and you can start driving from one place to another. So it's a very fast charging method called mode 4 charging. Let's see in detail. So these sunlight hits the solar panels, automatically the power generates. So this DC to DC charge controller regulates the battery. A charge controller, this is a country. This is called a battery management system. Whether the battery is in good condition or not, whether the battery cells are in good condition, and whether it seats in good condition, whether here we have to charge or not, how much amount of we have to charge the batteries and how long it took. So these are all the control unit will take care by sensing the various parameters of the battery, by voltage sensing, current sensing, even the temperatures also. If the temperature of the battery is too high, it won't charge. So these are all the conditions we are working in our company and other companies to give a specified and efficient charging, right? These are all the e-vehicle charging stations. See the first image, it was located in Pune, right? This electric vehicle charging station, they are charging the batteries. This was initiated by the Tata Power, Tata Groups, and this solar charging station, see, similar to the petrol bunks, similar to the design, they have used the solar panels to generate electricity, and they are giving a supply, right? Okay. The next one is also the DC charging station. These are all the for auto rickshaws also they are charging. DC rickshaws also they are charging, and then cars, bikes. So these are all charging. Okay, the session is going to end now. I will reconnect it back. Thanks for your patience. I will reconnect it back. Thank you. Please be online.
இந்த வந்துட்டாரு இதுல hello.
Yeah, hello.
Sir.
Yeah, let's continue.
Yes sir, start sir.
Yeah, okay. So coming back to the point, and this is a DC charging station located in Mumbai. They're charging their e-vehicles also, and it's actually it helps our environment to get to avoid from the global warming and it avoids global warming and greenhouse effects also. Okay, conclusion. So what I'm concluding is we have some videos.
நான் பாத்துக்கிறேன். என்னாச்சு? Hello, sir. Selvaganai sir, can you hear me? Sir? Selvaganai sir? Sir, excuse me. Selvaganai sir? Sir, excuse me. Can you hear me, sir? Sir? Sir, excuse me, sir. Hello, sir. Selvaganay, sir. Can you hear me, sir? Hello, sir. Selvaganay, sir. Queries report. Hello, sir. Selvaganay, sir. Selvaganay, sir. Selvaganay, sir. இங்கே ஒன்று வருது.
நான் ட்ரை பண்ணிட்டு தான் சார் இருக்கு. Okay,
yes,
okay.
sir. Yes, sir. Yes, sir. Connected. Now connected, sir.
Yeah. Sorry for the hello. Yeah, sorry for the interruption. That there is a technical issue. Sorry for the interruption. Let's start the session. Just a minute. Let's start the session. Sorry for the interruption, audience. Okay. So these are all the charging station we have already seen. They are using in Mumbai and various locations right here. Okay, let's have conclusion. Let's see some of the video session. We'll complete within 10 minutes. Okay, we will complete within 10 minutes of this video session. So what they are doing is whether we will see, right? Okay. And see, and this is the guy speaking, right? And this is a charging session. This was developed by Echo EO groups, right? So this is he have installed it in the installed on the home itself. So This is a company. This is a made in German company, and this is a Evo Mini basic, and it have various variants that. So he's using this socket to connector. He's connecting there, and he's plugged it into the electric vehicle. So he's fitting. So after that, this see right here, there is a box that is called a power conditioning box, which have a communication between the electric vehicle and see. So you can see right here whether it's you can see the charging conditions, and see it's showing it's charging. So similarly, he is charging. In future, we also will install this type of features in our home. The next one is and see the installations. See right here, they are installing EV, electric vehicle supply equipment. So they are installing. So they are placing. This is the DC charging station. They are placing. So they are programming and they are commissioning what all and the safety measures they are doing. So getting into the EV, they are connecting the cables right here, and they are billing as it is, and they are charging the batteries of the electric vehicle, and after paying the amount, they are moving, right? So similarly, we will also do it on one day. And this is a faster growth even in southern Tamil Nadu, even in Tirupati, they are using electric vehicle to travel to allocate the pilgrims to one place to other, right? So these are all the videos. So next one is homemade charger. See this homemade charger. I want to show this homemade charger. So he's using electricity grid. This is called level 1 charging and level 2 charging. By using the utility grid, he's going to charge his batteries, and it's completely it's a homemade one. They are using SMPS and some components to convert AC to DC operation to charge the batteries, and this method is quite less efficient when compared to the DC charging. So because everyone cannot able to install the solar panels and have a DC charging, right? So automatically this AC charging have only one disadvantage, that it consumes more time to charge the battery, and regulators and other much of units to charge the batteries. Okay. Okay, let's complete the session. And thank you.
Thank you, sir. Thank you for your wonderful presentation. So,
thank you.
Sir, can I go for a query, sir?
Yeah, sure.
Yes. Mr. Subramanian, sir.
Yeah.
Sir, I unmuted you, sir.
Yeah.
You may raise your query, sir.
Today is a very good topic, electric vehicles. What you give
Thank you.
Is electric vehicle. So you have nicely
Thank you, sir.
presented. I have two questions before you.
Okay.
Mr. Selvaganathan, I have two questions before
you. Go ahead, sir.
Yeah. The first question
go ahead, sir. Go ahead.
You have said regarding the charging stations.
Yes.
particularly in remote places, what is the effect of charging station on electric vehicles? I think you got my point.
Yeah, for remote station in the sense, can you able? Yeah. Yes. To repeat the question, sir.
Hello, your voice is breaking.
Can you able to repeat the question?
Yeah, particularly in remote places, because
am I audible?
Electric vehicles in remote places.
Yeah, am I audible?
Yeah.
Can you able to repeat the
Your voice is breaking, sir.
Okay. Yes. Yeah, I don't know what's happening right here. It's a connection issue. Yeah. Can you able to see?
Yeah, I'll repeat my question.
Sir, is this tell me.
Now, when we are using the electric vehicles, particularly in remote places, what is the effect of charging stations on electric vehicles? Because charging stations in remote places is a challenging task.
Sorry, I am reconnected now.
Yeah.
Your question is you have to what are all the issues in remote locations, right?
Yeah.
Yes. Hello, sir.
Yeah.
Okay. Coming to the point that similarly we have during olden periods, these are all the issues faced by the petrol bunks and fuel stations also, right? Fuel stations also. So now see, in 2020, we can able to see the fuel station in each villages also, right? So like that, it will take a time, and they will install it on the remote locations also.
Okay. Another question is that which type of batteries are used in electric vehicles with more efficiency and other features what you have discussed now. So, and what is the specific reason for that?
Because it's a less in weight. Okay, if you are using some other batteries, it will be very weight and its mass will be very big. So we cannot be able to run the EV vehicle with greater speed, and it has some aerodynamical issues. So we are using lithium-ion batteries for better efficiency. So currently they are updating lithium-ion batteries for better efficiency, and actually it's a less in weight, and it will get fastly charged, and we can able to use it right, because its C rating is very low. We can able to have more. We can consume more current by having more number of people can travel in a single vehicle. So which they are equalating to the normal fuel vehicles.
Okay. Just sorry for the interruption. Just one more question.
No issues, sir, you can ask.
Yeah. When do you think that in India we can launch the electric vehicles more and more?
So it's a complicated question and a hypothetical question also. So better. Actually, it depends upon the politicians and other major issues of our economy. So I think it will be soon launched. Actually, many people have launched in even southern Tamil Nadu. They are using even in Tirupati also. They are using many electric vehicles and having many charging stations and all. Let's see. We are expecting within 2030, like what we are having a fuel station, that is petrol stations right now. I'm expecting on 2030. So it depends upon our economy and politicians.
Yeah. Thank you.
Okay. Thank you. Yeah, next question. Hello. Yeah. Any questions? Hello.
Hello.
CSR Engineering College. Staff.
Hello.
Sir.
So,
Can you
Mr.
able to read
Jagannathan?
Yes,
can
sir,
you
I'm
able to
Jagan.
redirect them?
You are unmuted now.
Sir, I'm Jagannath, Dr. Jagannath from Telangana. Hello.
Yeah, okay. Nice to meet you, sir.
Sir, in the second slide, you have shown AC to AC to DC charging point. You have connected AC grid and to that AC, and again you are converted into DC. Then why can't you replace the DC motor with AC? That is my first question. And second question is why we are going for we are depending upon the generated energy. Why we are totally depends upon the solar panels. Why can't we install our solar panels on the vehicles?
Solar panels on a vehicles gives a lesser efficiency because there are many types of panels they have developed in recent days, like flexible solar panels and all. So according to my point, the solar has many issues and many maintenance, like effect of temperature, sizing issues, tracking issues, cleaning issues. So lots and lots of issues are there in the solar panels. So in order to have a solar panels on the top of the electric vehicle, actually it's settled up to the project state only. It's not up to the product state. If you are using the solar panels on top of the vehicle, it will be helpful only, but you cannot be able to travel, and this maximum power cannot be used right there. So the R&D is going on, so we are working on it.
For my first question, why can't you have AC to again DC? Why can't you replace that DC motor with AC when we are taking charging from the AC?
Yes, sir. What I'm trying to say is, shall I share my screen? Just a minute. I will share my screen. I will explain you with the diagram. Can you able to see my monitor?
Yes, sir.
My screen, right? See what's happening right there is just a minute. So you are asking about this, right? This rectifier concept of okay.
Yes.
So instead of using this DC controller, you can use AC, right?
Yes.
Okay. So why I'm asking is because we are using batteries. Batteries can have only a DC power, right? So we cannot able to directly give. If you directly give, the wire should come along with us. So we can, if wireless electricity have been invented, we can develop your method. But instead of we are using batteries, so we cannot be able to directly have a utility grid or other option. And another thing that only in India, only 30% of people are using solar and renewable energies. Okay, so remaining people and all, they are mainly depend upon only the utility grid only. So everyone cannot, because even in a specific location, we cannot able to have that much of solar panels in our home, right? So this is abundant. So this we can use the EV grid for a shorter period. In future case, we can use the solar panels for charging the batteries. Sir, can you able to understand?
Okay, sir. Yes,
okay.
Yes.
Yeah, okay.
Thank you, sir.
Thank you. Yeah, thank you. Next question.
Hello, sir.
Yeah, hello.
Sir, this is Vijay.
Vijay.
Sir, actually, I've been working with e-vehicles for the past 3 years, sir. Working in the sense, I have a set of students for making e-vehicles.
Very good.
We are participating in several competitions, national competition, and we have been experiencing so many things, sir. The thing is about batteries in India. As you said, it depends on politician. We all know that. But the cost of the battery plays a major role in the design of vehicles, sir.
Yeah, sure. Yeah, I am accepting. I am setting your point, because battery is the heart of this overall electric vehicle, and actually it is too costly, and it also, so better we have a manufacturing unit on India to give a with lesser budget, right?
Yes, sir.
Yeah.
But
we should take steps. We should take steps instead
Yes,
of
sir,
having.
yes, sir.
Yes.
If
Yeah.
government is taking steps to more number of companies producing battery or they're producing in a good way, means it will be helpful because it is costing around 1 lakh. The total cost of the vehicle itself is only 2.5 lakhs, 3 lakhs, but the batteries are costing 1 lakh 10,000 or something like that.
Yeah, actually, it's almost 80% of the total.
80% of the cost is actually directly occupied by the battery.
Yeah, okay. Let me tell one short story that during earlier times, similar like these charging stations and all, like the normal conventional vehicles cost will be very high, right? Did you remember, right? So
Yes.
after coming to from the current scenario 2020, you can able to have a parts, right? If your parts gets damaged, you can easily go and buy in some automobile shop, right? So
Yes.
whatever happens, we should we will take a time for that, right? We will take a time.
In India, it is not new, sir. For the past 4 years, we are attending this competition. It is not new, but still we are finding very difficult companies selling batteries. Still,
Yeah,
it is not developed.
Yeah, I can able to understand your pain because I too have worked in that. I too have lots of emotions that they are not much taking care of this batteries and all, because we too have purchased this battery from China or some other countries. So what to do? So again, I'm coming to the point. Our economy, and we have to take steps, right? And so instead of concentrating on projects and making. Like China, we have to concentrate on the product side. We should have a manufacturing unit for each village and each district and each state also, right? And this is the right method, right? So instead of doing lots of projects, lots of theoretical sessions for the students and for upcoming students, better we can imitate China for having a manufacturing sector for each village, for each district. So it may in future it may helpful for reducing the batteries cost.
Yes, sir, correct. But of course, you talked about charging station also.
Yes.
As far as I know in Chennai there are 2 charging stations, sir. In Mumbai,
Yes.
But charging station is also not increased because nowadays we are starting to e-bikes also, and of course e-cars are also like hitting the market.
Yes.
But charging station is very mandatory for all these things, right, sir?
Okay. Yes. Let me come to the point that usually Indians have a mentality that we won't have go to the newer one, right? Because if everyone is using one, that only the respective person also will use. Okay. We won't upgrade it to the newer one because we have issues. If you are buying the electric vehicle, if you got problem, where we go and tell the problem. So many issues are, right. If you are converted the normal conventional vehicle to the electric vehicle, all the mechanic shop will be closed and it will reboard and it rename as a name according to the electric have like. Hello, is this audible?
Yes.
Actually, all the mechanic shop will rename to an electrical shop, right? So everyone will have a change in that. So that only.
Yes, correct, sir. But as far as electric vehicle is concerned, maintenance is also very less. But still, people not aware of this.
That only people are not adopting to a newer one. They are not upgrading. So youngsters, we should take care of that, and we should make a craze about the electric vehicle to the upcoming economy to the next year.
But in North India, there are some awareness. In South India, it is very less.
Yeah. Okay. So actually, that not only the government should take care, even the people should have, like corona issues. They are all we are all locked in the home, right? We should have take care of us and take care of others also, right? So like that, we should take care of our environment also. So everyone should have this basic things, and students should have a craze of doing unwanted projects. We should have concentrate to improve our environment and economy. Like this, we should have a manufacturing plant of batteries.
more on
Yes.
e-vehicle side, sir.
Yes, e-vehicle side, etc.
Thank you, sir. Thank you.
Thank you. The next question.
Mr. Ramarao.
Yeah, good morning, Salvaji.
Yeah, good morning.
I hope you remember me, Dr. Ramar. Yesterday, we were discussed about the design of a solar plant for water purification.
Yeah, that's 5 kilo, that is 5,000 watt water plant.
Yes, sir.
Yeah, you're talking with me, right? Yeah.
We had very good session on electric vehicles, sir.
Yeah,
Actually,
okay.
somebody asked that when are you going to get more electric vehicles in India or on Indian roads, something like that.
Yes.
And in the month of January, I attended an international conference where of course, one person from Vijayawada, I'm staying in Vijayawada, who is working in Germany, came here to give an expert talk on electric vehicles, and really showed so many challenges for India, especially to come electric.
Especially to India, right?
More in number onto roads. Actually, are we ready? That's what actually he showed. So many challenges. Are we ready? Is our country ready? Okay, to accommodate more electric vehicles or to bring in more electric vehicles on roads, especially what you said, charging stations, infrastructure, charging station. That is one challenge actually. So far, I think I am not also seeing that there is no witness that charging infrastructure is increasing in India. So still we are lacking the charging infrastructure.
Yeah, but there is a charging station, right? There is also some of a charging station like point. Even in
points
the
are the plug-in, plug-in points are there here and there, but on highways and all, there's no infrastructure, it seems, because of course I am not a good traveler.
Actually, they have not completed yet. And they are thinking and they are overthinking to establish this concept.
Yes.
So instead of putting so much of money in the electric vehicle and electric vehicle charging station, better we can concentrate on the normal stations, right? They are seeing current status and current profit only. They are not people are not ready to have a larger vision to save our economy and
green energy perspective.
Yes.
That too. One more thing, actually, what I came to know that through his session, that person, battery reliance, because there are maybe some accidents may take place. Of course, because vehicles are there, so that no doubt that we can expect. And usually accidents may take place. No exception for electric vehicles also. When accidents took place, okay, electrocution or fire accident, and because these are all high voltage EVs, something like that. Okay, he showed actually BMW and other high-ended cars also showed the accidents, and when people are trying to attempt that rescue, that they got electrocuted and severe burns and severe injuries like that. So these are all issues. Actually, there are various issues actually showed up. Because we should be ready actually before bringing all these electric vehicles onto our roads. That is one thing I think one point actually we have to think of. If people are really want to do some research, even battery package and battery safety, battery security, safety, and these are all the things. Of course, my question is for you, Selvaji. You have shown 3 types of charging. Of course, somebody asked that, even Vijay or somebody. See, all 3 at a time, or just these are all 3 options you are showing?
Actually, it's an option. We cannot able to charge one battery with the 3. Okay,
then in that case, actually, okay, that's good. Actually, I also understood that the options actually 3 options are there. So in that case, actually, what is the efficient charging system? And while running, actually, if any battery is getting down or discharging, of course, to a low level, something like that. So while running, so what is the remedy? Of course, leave that hybrid electric vehicle, only with a pure electric vehicle. So I want to know. So what is the best remedy, okay, to charge the battery immediately while running? Suppose we have not yet reached the destination, 10 kilometers is there, or some 50 kilometers is there, something like that. And what is the efficient charging system out of all these 3 options? Got my question, sir? Am I audible? Salvaji? Hello?
Yes, I can able to.
Yes.
Sorry, I can able to answer your question. First of all, I just want to clear one thing. Efficiency. Can you able to hear me?
Yeah, yes, sir. Yes, sir. But little bit voice is breaking.
Can I able to understand your question?
Sir, we lost our voice. Audio is not coming, sir.
Sir?
Yeah.
Selvaganesh, sir?
Yes, sir.
Selvaganesh, sir? Selvaganesh, sir, can you hear me?
I think you lost network.
Yes, sir. Maybe some technical issue.
Yeah, yes, sir. Sir, you are host. Sir, are we able to get the PPTs and all, or otherwise Excel
Sir,
sheet?
sir,
Yesterday we asked for that Excel sheet.
Yes, sir. Yes, sir. We requested.
Yes.
We requested Mr. Selvaganesh, sir.
Yes, sir.
So we will send you as early as possible, sir.
Yes, sir. Thank you.
Yes, sir.
I think Sir has lost the connection.
Maybe, sir. So, but
no problem, sir. You can answer me also through some chart.
yes. We will try to connect him, sir.
Yes, sir.
He may lose the signal.
Yes.
Sir, Selvaganesh, sir.
Yeah, I'm back.
Yes, sir. Yes, sir. Yes, sir.
Yeah, okay. Sir, one person, Ramarao ji, are you online?
Yes.
Yeah, okay, yeah. I can able to understand your point that what is the efficient method, right? You are asking about the efficient, which charging is efficient, right? So, according to my point, efficiency is the only thing that depends upon your applications, right? And whatever it may be the applications only, it depends upon your efficiency, right? So, for having a 10-kilometer distance, you are traveling a 10-kilometer distance, you should have this much of specified batteries. You should have a specified batteries with the specified ratings. So, according to the sizing. So, for an emergency situation, we can have solar panels on the top of the electric vehicle to get park in the sunlight area, and by getting the charge, and we can travel, and we can start travel from one place to other. So this is the simple thing I can able to do.
Yes.
Okay.
Yes. Thank you, sir.
Yeah, thank you.
Mr. Dekar? Dr. Dekar?
Dekar.
Yes, sir.
Yes. Sir, my question is, can we use the regeneration for charging the battery?
Sorry, regeneration
possible.
Sorry?
Regeneration to charge the battery in vehicle itself.
Regeneration, yeah, actually it's in a conventional vehicle also, they are using the same method only. They are using the dynamo, right? The wheels are rotating, right? By using the dynamo, they are converting the AC to DC, and then they are charging the battery. So we can use that. Okay, I will show one thing.
No, what is my concept is, sir, that is hilly area, that when slope is there, the speed will be greater than the rated speed. So same acts as a generator.
Okay.
So with the
actually,
same motor, can we charge the battery?
Actually, it depends upon the design. Actually, the rated depends upon the rated design. So whether actually I'm not working on that part, so actually I don't know. Better I will consult with my concerned persons and I will share the results. Right?
Okay. My second question is.
Yes.
That is any research going on to reduce the charging time of the batteries?
Yes, it's going on because as I was explained earlier, we are using type 3 batteries, C3 batteries and all. So C rating will be very less. They are working on it, right? Within 5 to 10 minutes and all, it's they are charging the batteries. So like let's have a for the tea break and coffee break, the batteries can be able to charge completely, and we can travel.
No, it may be the special.
On it, right?
No, it may be the special type of batteries, but for normal batteries,
yes,
can we reduce the charge? For normal batteries, can we reduce the charging time?
Yes. Before that, I just want to say one thing. If you are going for any function, any occasion, there will be abundant amount of food, right? Yes, there will be abundant food, right? But we cannot able to consume all the food. Actually, in this scenario, we are the load current. We are the battery right here. We cannot able to consume that much of current is there in the grid or the charge controller can give. What we need, we will consume. Like that, the battery will have a special characteristic that it will charge. Normal batteries will charge only 10 to 20% of this capacity only. If you can able to give 100 amperes of DC current, but the battery can consume only 15 amps to 30 amps only, according to its battery characteristics. So if you want to have a less charging time, you have to have a go to the next side of batteries. That is called we have to improve the batteries, right?
No, my opinion is,
okay,
if we reduce the charging resistance.
Okay.
So
அவர் முதல்ல உள்ள வரட்டும். Sir, Selvaganai sir.
Sir, yeah, I came back.
Now connected, sir.
Yeah, okay. Sir, are you online?
Yes, sir.
Yeah, okay. Someone else have asked doubt.
Yes, sir.
He's online or?
No, I don't know.
Okay.
Doctor, yes, sir.
Yes.
I unmute him, sir.
Yeah, okay. Yeah, hello.
I unmuted him, sir.
Yeah, okay. Yeah, hello.
Sir, just a minute, sir.
Yeah, okay.
Hello, sir.
Yeah, sir. Yeah.
Sir, the charging of battery.
Can you able to repeat the question?
Can we reduce the charging time of normal batteries, like reducing the charging time constant? That is R value. If we reduced, so it will take less time to charge. So if it is possible to reduce the resistance by any means, if we have the resonance conditions, so due to the resonance condition, the resistance will drop and the time will reduce. So
yes, actually, so they are working on it. Yeah, they are working on it. Actually, what you have told is actually it depends upon the manufacturer side of the battery. So in order to reduce the charging current, the manufacturer should take care of it, and the design changes should be done by their manufacturer side and their design engineers only.
No. It will not the internal part of battery. It is external to the battery.
Yeah, you can have a separate controller for that. So actually, first of all, I just want to say one thing that whatever may be your external controller or external device, what you have done is the battery the design characteristics, the design curve and the design characteristics remains the same, right? So we cannot able to do that. Even though you are using an external controller, external circuit, the battery's charging characteristics have only a 10 to 20% of its capacity only. For lithium-ion batteries only, they are upgrading it to 30 to 40%. See, if you are upgrading the charging current of gradually, you can able to reduce the charging time. So even though you are using external controller, that only I will tell you, if you are going to the function, they're having that much of abundant food right there, but you cannot able to consume, right? So, but I can able to consume this much, only smaller amount. Some people can consume more amount of food. So it depends upon the design of those specific batteries. So can you able to understand? Even though if you are having external circuit, it depends upon the manufacturing part of it, specific battery. Yeah.
Okay.
I got it, sir. Yeah, got it, sir. Thank you. Thanks.
Catherine? Miss Catherine? Hello? Miss Catherine?
Just a minute.
Nice.
Yeah. Okay. Hello. Good morning.
Yeah. Good morning. Good morning, ma'am.
Very regarding that battery life, one thing, and how to dispose these batteries, because always battery disposal is a main issue anywhere, whether we are going for PV energy or we are going for the EVs. So
yes. Yes, ma'am. I can able to understand that. How will you dispose those batteries? Okay, right after it gets damaged or after the required time, so much of years, we should dispose it, right? Even it get bulged. That's like you are asking, right? Yeah. Actually, I'm working on as total plant engineering and design. So nearby, some other companies are taking care of this disposing of batteries, and they are renovating. That is, they are recreating into new batteries. So I was spoken with one specific person that there are 6 methods of recycling the batteries. So I'm not familiar with that 6 types of disposing and recreating. Anyhow, I will contact him and I will ask and I will share my details through your mail, ma'am. Kindly you can mail your mail address. I will share the details.
Okay. And one more thing.
But there is 6 methods of disposing.
Okay, because when everyone is using by 5-6 years, once everyone starts using this disposal, everywhere it will get piled up. Okay, that's one thing. And one more thing, what is the mileage at present? Hello?
Mileage to ma'am there.
Yeah.
Mileage in the sense, ma'am, mileage, it depends upon how much of load you are getting into that electric vehicle. If the one person drives the vehicle, it gives more mileage. If 2 persons or 3 persons get into that vehicle, the mileage will automatically reduce. So mileage depends upon the person's riding on that specified electric vehicle. So for example, for instance, I am saying if one person is driving in a recent, in 2019 scenario, more than 143 kilometers they have developed, ma'am. And after 143 kilometers, they put a charge and they will travel back.
Okay, that means what will be the weight of the car?
Weight of the car in the sense, sorry, ma'am, I'm not familiar with that weight and design criteria. Because
person's weight should influence, means weight of the car will be very less, because in our normal diesel vehicle, the weight of person or number of persons will not have much effect.
Yes.
Okay,
actually these criteria and all, it comes under the design part. Okay, actually we are not undergoes any design issues. So actually I don't know that what are all the sizes, weight issues, because lots and lots of calculation is there, right?
Okay.
Yeah. Okay, ma'am.
Okay, sir. Thank you very much.
Okay. Thank you. Thank you.
Thank you.
Hello.
Yeah, hello.
Hello, sir.
Yeah.
Sir, good morning, sir. So
good
your
morning,
session was very good, sir. First of all.
Thank you, ma'am. Thank you, ma'am. Thank you, ma'am.
So just I have only one question that I want to know that the factors which affect the discharging of battery, sir, in electric vehicle, and apart from all, which will affect more, whether it is on speed condition or load or braking, or which factor will affect more in discharging of batteries?
The first condition is a temperature, right? The effect of temperature plays a vital role in discharging of batteries. So nowadays they are designing to withstand the temperature, because normal conventional vehicle and all, we will travel to the long distance, right? Okay, like similar to that, increases to the certain level. Yeah. So effect of temperature is the main criteria. Hello, ma'am. Can you able to hear me?
Yes, sir. Yes, sir.
Yeah. For the effect of temperature plays a vital role in discharging the batteries, and yeah, that's it.
Okay. Thank you, sir.
Yeah. Thank you.
Hello.
Gabriel Santosh Kumar.
Hello, sir.
You are unmuted now, sir.
Yes, sir. Sir, is there any new technology evolved? The special machines are designed other than BLDC is designed or in the R&D for this electric vehicle?
No, currently they are using BLDC and BLC motors only. Maybe in future they will upgrade according to our customer needs and customers' requirement. Maybe I'm not familiar with now that right now, but currently they are using BLDC and BLC motors only.
Okay, sir.
In DC applications.
Okay, so
in
regarding
DC
charging,
operations,
okay,
not in AC station. Yeah, go ahead.
yes, sir. Actually, regarding charging station, there was some discussion. Is there any change or any type of charging? But actually, some research is going on. That is like as we have in our phones, right? Voc charge, VWC, that is fast charge, burst charge, right?
Yes.
That kind of charging is
Okay. Let me
research, I think, sir. Because sir was asking, I'm not able to remember, but that kind of charging is planned and it is also used in some kind of vehicles. And the distance is also increased around 500 kilometers in the latest Tesla S-type model, I think.
Yeah.
Recently, I've heard it in a webinar session. So the technology is improving very faster, but fast charging is also available in the current scenario.
Yes, it's available in the current scenario, but I just want to convey one thing. Let's actually. Hello, is this audible?
Yeah, yes.
Yeah. First of all, I just want to convey one thing, that even though these the performance have been improved, there should be there will be a character for the specified battery what they are using. Okay. Like someone have asked right before, right? It should have a specified charging current, right? Yeah, it should have a specified charging current, so that battery should capable of accepting the fast charging. So now you
correct, but thing is that all commonly batteries will accept the charge, but the performance of the battery will vary.
Yes, that's only I'm trying to say. If you fastly charge the batteries, it will fastly discharge. So you should
other characteristics will also vary, but it is not. We cannot say it is not incompatible, but it is compatible. However, but the characteristics of the battery will vary and deteriorate in due course of time.
Yes, so you are correct. Actually, totally I'm concluding that it depends upon the battery manufacturers only. So he should give an option, right? If you are going to buy a new mobile, the respective manufacturer like Redmi or Lenovo, what are all the companies in the market, they try to show that, right, it is a fast charging. 5 amps charging, 6 amps charging. They will have a specification data sheet at the back of the mobile phone, right? So similar to that, the battery manufacturer, the battery manufacturer should enclose these data sheets and things to the customers to have to get more ideas about that.
Yes, sir. Yes, sir. Yes, sir. Correct,
Okay.
correct. But new charging technologies are available. That is what.
Yeah, they are developing. Yeah, they are developing. We cannot able to update, right? If you are R&D on one specific part only, we can able to get more knowledge. That's more knowledge.
The electric vehicle part is.
Yeah, it's going. Yeah, it's going on. Right.
Yes, sir. But now the electric vehicle is trying to move into autonomous vehicle side. So in future, moreover, electric vehicle they'll go for autonomous on the more side, it seems, because the trade is traveling towards that side. Actually, more opportunities are there, sir. Thank you, sir. Thank you.
Yeah. Okay. Thank you.
Manimala Gopalakrishnan. Manimala. Mrs. Manimala. Mrs. Manimala Gopalakrishnan. So, Mrs. Manimala Gopalakrishnan, I unmuted now. Please post your question.
Hello.
Yeah, hello.
Yeah, good morning, sir.
Yeah, good morning.
I'm having some questions, sir.
Yeah, ask me, ma'am. Go ahead.
Are you hearing, sir?
Yeah, ma'am. It's audible. Yeah, it's audible. Go ahead.
The more number of DC to DC converters are available in market, sir. Which type of DC to DC converter is used in electric vehicle?
Okay. And then coming to the point, you are asking about the DC to DC controller. Which type of DC do you have to buy, right? So you have to check the two. You have to check the two parameters. One is battery voltage, that is battery's characteristic, that is called voltage and capacity, okay, of the specified battery. And then second thing is you have to take in charge of that DC load, that is called a DC motor, what you are using. So according to their input battery and output load, you have to calculate accordingly and you have to purchase. So if you can Google it, in Google they have a separate automatic link that if you have input the battery voltage and the load that is a motor characteristics, that is a motor rating, automatically it will conclude and give you the result of these are all the types of charge control. You can install it on your system. So there is a option in Google that it automatically generates if you input your if you give you the input of a battery and load, that is called AC load, AC motor or DC motor load, it will give the specific controller what you have to use. That is even with the rating also. And in the below links, they will give many links to purchase also.
Okay, sir. Which is the best efficiency? Which gives the best efficiency?
Efficiency in the sense, what efficiency, ma'am? May I know?
Overall efficiency of this.
You are asking about AC operation or DC operation, ma'am?
DC operation, sir.
Sorry, DC or AC, ma'am?
AC, sir.
AC, ma'am. Actually, the efficiency, I am repeating that efficiency depends upon your application. If you have to travel faster within a specified time, you have to go for an AC operation, AC electric motor or AC electric vehicle operation. If you want to go steady state, if you have to go to steady state and if you have time, you have to travel in a gradual manner, you can choose a DC operation. When comparing with AC and DC, AC is very cost effective and DC will be a very much less effective. And it depends upon your application. If you want to go fast and if you have many options, you can better choose AC operation. If you want to go in a gradual manner, you can have a DC operation.
Okay, sir. One more question, sir.
Yes. Yes, ma'am.
What are the various, what are all the storage facilities available to store the electric energy in electric vehicles other than battery?
Other than battery?
Yes, sir.
Storing. I'm not familiar about that. Recently, everyone is using battery only because battery is one of the storage DC source, right?
Yes, sir.
So which can operate. So instead of using batteries, so
Anything is possible to.
no. Actually, without battery, we can fit the solar panels on the top of the electric vehicle, and you can run the electric vehicle, but it won't be much more effective when you instead of using batteries. So during night time, you cannot able to travel, right? Because there will be no solar irradiation. So to alternate for DC energy source, I don't know. Actually, I'm not familiar with that.
Okay, sir. Thank you.
Yeah, okay. Yeah, okay.
Dr. Newlin Rajkumar. Dr. Newlin Rajkumar. Dr. Newlin Rajkumar. Sir, I unmuted now, sir. Dr. Newlin Rajkumar. Mr. D. Tamil Selvan. Mr. D. Tamil Selvan. Mr. D. Tamil Selvan.
Hello, sir.
Hi, sir.
Yeah.
Sir, very good morning, sir. It is a nice session.
Yeah, very good morning. Thank you.
It's a very nice section, sir. Just only one query, sir.
Yeah. Go ahead. Thank you.
There is only one query, sir. I am having.
Yeah, sir. Go ahead. You can ask.
Okay, sir. Is there any other cooling method, sir? If you travel for a long distance, means the engine will get heated.
Yes, sir. You can ask. Yeah, there are. Yes, sir. There are lots of cooling methods done in car also. Yeah, because the effect of temperature plays a vital role in batteries efficiency. So yeah, they are using many cooling methods, but we are working on that. So I will tell you later. Can you post your email ID? I will just share the details.
Okay, sir.
Okay, actually we have started and working on it. So that's why.
Okay, sir.
That's why I'm telling.
Just another one query, sir.
Yeah, you can ask.
Sir, normally we have started the DC motor with two types of starters, 2-point starter. Is there any other method of starting that electrical vehicle?
Yeah, actually, it's inbuilt in that specified control unit, right? It have a specific. There are many types of DC starting, right? For DC motor, there are many types of starters are there. So according to the DC motors rating, we will purchase a conditioning unit, right? Power conditioning unit, right? So in that power conditioning unit itself, it has a inbuilt self-starting options. It will have self-starting options in that power conditioning unit.
Okay, sir. Thanks, sir.
Yeah, okay. Thank you.
Mr. Kalpesh Mahajan. Mr. Kalpesh Mahajan. Mr. Kalpesh Mahajan.
Hello.
Sir, you may ask your question, sir.
Sir, I having one question. I heard about the super capacitor. Yes, sir. I heard about.
Yeah. Can able to hear? Continue.
Yes. I heard about super capacitor are useful for improving the battery performance or battery life or efficiency, sir. Can you say something on this?
For example, in your home, you are using a fan, right? Ceiling fan.
Yeah.
Yeah, it has some condenser, right? That is also a supercapacitor.
Okay.
Yeah, similar, like same concept. If you are, why they are using a supercapacitor to the batteries is, can you able to imagine if you go and on your water pump motor in your home, automatically all the electrical load will fluctuate with some amount of time and it starts and get back to the normal position. Okay. Similarly, when you are starting the electric vehicle with some much of load, the battery's volt, the inrush current will affects the battery's voltage. So in that time, they are using supercapacitors to overcome these problems. Like ceiling fan, it has a condenser, right? Like same options.
Okay, sir. Okay.
Yeah, okay. Did you understand? Got it?
Yeah, yes, sir. Yes, sir.
Yeah, okay, right.
Thank you.
Sir, Selvaganai sir.
Yeah, sir.
Shall I ask some question
Tell me, sir.
which was posted by the participants in chat box, sir?
Yeah, sure, sir. Yeah, sure.
Sir, what about vehicle to grid technology? Vehicle to grid technology.
Yes. Okay. If a battery gets charged, actually, see the if your battery is not, if a battery is in 50% of charge, if you go and stop it in the sunlight, it will start charging to. It will get charged up to 100%. So after 100% of charging, the solar radiation gets wasted, right? So on that time, like a charging station, also the export station can also be developed. The wires and others to our cars to export it to the grid. And this is also the one of the best method. See some of the people stop their vehicles and stop their vehicle on the sunlight during parking. On that time, we can connect the EB grid box and we can export it to the grid. And this is also the good idea. We can accept it for the project purposes also.
Sir, another question, sir.
Yeah.
So, in your point of view, how long it will take for all the vehicles to be EV based?
No, actually, not all the vehicles will be EV based. Only it have both hybrid options. It won't completely transfer into the 100% of the battery operated vehicles. It have both the hybrid option. Whether we can use gasoline or I think it's around 2030. We all must change. We will change. Hello.
Sir?
Yeah.
Sir? Next question, sir.
Next question.
Sir, I have a specification on EV like 100 km per charge. How much load is considered in this specification? Is there any mileage term in EV?
Yes, mileage term in EV. Already, as I told earlier, if one person is driving the EV, you will get 100 kilometer, right? You will get a mileage of 100 kilometers. Same thing if you carry any loads, right? If you're traveling with any other persons, automatically you won't get the mileage of 100 kilometers. You will get only up to 80 or 70 kilometers only. It depends upon the concerned person sits behind you. So mileage is a thing which this kilometer is a thing which depends upon the load. The person who are occupying the electric vehicle.
Okay, sir. Thank you, sir. Sir, one more question, sir. So, what is the average and charging time of vehicle, sir? Is it feasible for long journey?
Average charging time of vehicles. So, I guess if a petrol or diesel got empty, we will go and fill it back to the separate fuel station. Like that, similar to that, it's not applicable for long. For current during 2019, for the updated current scenario, they have traveled up to 533 kilometers, not more than that.
Oh, okay. Thank you, sir. Sir, final question, sir.
Yes, okay.
How can we design 48-volt BLDC motor?
How can you design 48-volt BLDC motor?
Yes, sir.
Are you asking about the design of a BLDC motor, or
yes,
sorry?
The question was raised in chat box, sir.
Yeah, okay. Can you able to read the question again, sir?
How can we design 48-volt BLDC motor?
48-volt. Actually, it depends. Actually, it's depends upon the machine design. Okay, we have to. I'm not aware about that. We have to. Yeah, it will depends upon the machine design. That is, depends upon the manufacturer whether we can able to design for 48-volt operating voltage to 192-volt operating voltage. Actually, depends upon the machine designer. Actually, I'm not aware about that.
Okay, sir. Thank you, sir.
Okay. Yeah. Okay. Thank you.
Hello,
sir.
Sir, am I audible, sir? Sivaraman, sir.
Yes, sir.
Am I audible, sir?
Yes, sir.
Can I
Yes,
speak,
sir.
sir?
Yes, sir.
Good afternoon to all. I am Sivaraman, Assistant Professor, Triple Department, PSR Engineering College, Sivaraman. On behalf of our college management, Principal, Dean, and Department of Triple, I would like to thank our Honorable Resource Person, Engineer V. Selva Ganesh, sir, Electrical Project Engineer, R&D, Total Plant Engineering and Design Private Limited, Madurai, for wonderful and informative presentation about solar PV technologies and electrical vehicles. We are getting many positive feedbacks in the chat box for both sessions. We hope his speech will be useful to everyone and increase the research opportunities in the field of solar, photovoltaics, technologies, and electric vehicles. Thank you so much, sir, for being with us in these wonderful sessions.
Thank you.
I also
Thank you so much.
thank you, sir. I also thank all the participants for your excellent coordination and passionate listening. Thank you, one and all. Thank you, one and all. Dear participants, kind attention. The feedback link for the today's session have posted in the chat box. So participants kindly fill the feedback form as soon as possible. Only those who are filled feedback forms for all the 6 day sessions will getting e-certificates. Once again, I repeat, the feedback link for the today's session have posted in this chat box. So all the participants kindly fill the feedback form as soon as possible. Only those who are filled feedback forms for all the 6 days session will getting e-certificates.
One more announcement.
And sir, just a minute, sir.
Yes, sir.
And thanks for PSR College and my company Total Plant Engineering and Design for giving this wonderful opportunity. Thank you. Thanks a lot.
Thank you, sir. Thank you, sir. Okay. So one more announcement. So tomorrow we have a session on fax controllers application in smart grid. The resource person for tomorrow's session is Dr. N. Karpagam, Professor, Department of EEE, Velamal College of Engineering and Technology, Madurai. The meeting link will be sent to you before the session is started. So thank you one and all. So thank you, sir. Selva Ganesh, sir.
Yeah, thank you. Thank you.
Thank you, sir. Thanks. The meeting end now. Thank you.